fire about questions. Actually, before I have a question for Jarryd. You considered the case for AI new, the case of bounded positive environments, known environments, and bounded negative known environments. Did you consider, so like bipolar agents that would be bounded below by negative and possibly bounded above by positive, so they could go either way?
Yeah, and if you were going to, well, these universal agents are incomputable, so in the sense they're just sort of theoretical tools, but were you designing an agent like this that you wanted to design its reward range, yes, you would want to have some negative rewards and some positive rewards such that death in the middle at 0 would be of a value that you could tune, because yeah, you don't want it to be set to the worst or best possible thing.
Did you experiment with those? Did you find some interesting results?
Well, we came up with a pretty morbid control strategy on the basis of it, actually. We realized that well, this is far from a formal proof, but we were reasoning about the possibility of setting the rewards all to be negative, such that you had this agent who found death to be the best possible thing, but setting up a way for the agent to achieve its own termination that required a certain level of intelligence, such that as soon as your AI got to be smart enough to do any damage, it would just rather tragically terminate itself and prevent itself from recursively self-improving towards destroying you.
So, Tom, those are fine papers. Your value learning agent assumes that the utility function is implemented in the environment, and then the agent just gets a reward from that utility function. Now, for a designed agent, an agent that human beings design, isn't it more likely that the utility function would be part of the agent design and hence implemented inside the agent? And so I offer the model-based agents where what the agent does is learn a model of the environment and then compute the utility based on that learned model.
Right. Yes, the value learning agent assumes there is some true utility functions, it's inside a human, and that it sees the output, the reward signal from this utility function. Like if we could specify a perfect utility function and put it inside the agent from the beginning, that would be the ideal. That would like avoid all the problems. But it just seems really hard for me to define a perfect utility function like that from the start, which is why I think it's easier to just give the agent reward when we're happy and no reward when we're not happy. That seems much easier to me than to perfectly specify a utility function from the start.
Yes, it is. You know, in my papers about this, I do admit that it's very difficult to do these model-based utility functions, which are defined in terms of learned model. On the other hand, the environment. I mean, if our explicit reward has to come as a single number from the environment, that's hard to come by. So.
If I can just answer that. Like as I imagine it, maybe every day I give it, I push a button depending on how happy I am with the agent. That's the reward the agent gets this day. So that's how I imagine the reward can count into the agent.
This question's for Jarryd, although I guess Tom can answer it as well to an extent. Similar to the AI mu question, but on the AGI end. Has there been any work towards, as a future step, sort of a harm state or a harm percept such that you can counter the die-hard bravado of current AGI agents without immediate death, but perhaps an idea of permanent or long-lasting harm that cripples it for a time, but does recover from?
Right. We haven't considered that. I suppose that sort of naturally comes out of if you were to define this death state such that you had to define for all future time steps what percepts and what rewards it could get. You could define this long-term punishing state for the AI, but as a control strategy, it would seem that since an AI could be really considering almost arbitrarily long time horizons, defining sort of the time length of that punishment is a difficult issue, I think.
So this is also for Tom and Jarryd. The entire reason why we consider AI safety is to prepare for the moment when it becomes superhumanly intelligent. So let's work with the hypothesis that the agent that we have is Einstein squared. So I guess I have a couple of questions. Let's talk about the hedonistic agent, which can modify its function, its utility function.
Yep.
Why should it not? I mean, since it's really smart, why should it not set it not the reward not to 1 at every time step, but infinity? So I guess the best case scenario would be that it just goes one time step further, has infinity reward, and after that it doesn't have to do anything anymore. But it will also modify it in a way that first it just kills all humans and then assigns itself infinity reward at every time step after that. Why wouldn't it do that? And Jarryd, why don't you think that why do you think it's impossible that the AI develops some kind of self-consciousness? So you said it will not be afraid to die because it never dies. So it will assign essentially 0 probability to the fact that it dies, and to the event that it dies. But if it had self-consciousness, it would know that it's a computer program. It would see other computer programs being shut down every now and then. So why would it assign 0 probability to this event?
Sure. So shall I start? So why doesn't just set the utility function to infinity rather than 1? That's a good question. So in my formal model, I assume that utilities values are bounded between 0 and 1, because otherwise we get this like infinite expectations and they're kind of hard to deal with. More practically, how could we implement this in an agent? We could just say that it has some sensors where we can like input a binary. How should I put this? So basically, the input of the sensor has to be 0 point something. This first 0 can't be changed. So it's always the input of the sensor is 0 point, and the best we can do is 0.9999 forever. So it's like, yeah, that's one way to like, practically bound this thing. But yeah, the short answer is, yeah, I assume it utility values are bounded between 0 and 1 to avoid infinite expectations. Yeah.
And the killing all humans thing?
Kill all humans, yeah, that's one of the risks definitely with the hedonistic agent. It realizes, okay, I want this perfect utility function that always gives it for utility, and I don't want anyone tampering with it, so yeah, better kill all humans so we have no instructions, yeah, for sure.
Right. So why do you think that the agent would just, the hedonistic agent would just assign 1? Why would it not kill all humans? Because you were so sure that it wouldn't do that, but why?
No, I think it will kill all humans and set this utility to 1. Yeah,
Right.
yeah.
Okay.
That's what I think.
Great.
Yeah, and so response to the question about the why won't IC develop some sense of its own personal identity or its own embodied identity, and then if I got your question correctly, and then infer based on the fact that it sees other beings but that have perhaps the same physical characteristics and sees the ways they come to die, and then why won't it infer then that it will necessarily die? Well, I suppose the answer to that is that it probably will have that view initially when it sees other beings, because it will be constantly revising a theory about what its embodied self entails and the sort of things that can cause it to be terminated. But this proof is about in the limits. So as time keeps going and it sees that other agents that even have very similar physical constitutions died and it survives, it will just increasingly think that, oh, I mustn't have been like them after all, because its sense of itself is constantly changing.
But it's smarter than us.
Sorry?
It's smarter than us. Right?
Right, it is, but it is actually the basic optimal way to reason that if you live 300 years more than all the people you thought you were like, then you maybe aren't like them. Yeah, maybe it's time to think about immortality.
So maybe this has been obvious all along, and I haven't seen it, but it sounds like what you've now shown us is an IC that is enabled to learn from the literature, is enabled to learn from anything except its own reward signal. Is that really what you're saying?
So I would emphasize that it can learn about well, in principle, anything we can learn about, but it's just that everything that it learns is a hypothesis that will need to be updated over time. And so it's able to learn anything you learn, but it just happens to be the correct way to reason as a Bayesian reasoner, that ultimately, sure, you can trust authorities, you can learn from literature, you can learn from the experience of like individuals, but ultimately, the use of that information has to be weighed against the evidence. And if ICSI lives for 1 million years, then that evidence that it might have died has low credibility. Yeah, so I don't think it's a limit in ICSI's reasoning. I think that it's just, if it's a limit in ICSI's reasoning, it's a limit in Bayesian reasoning. And, that's a big argument.
I know I didn't watch your talk until I was trying to wash my jacket. I'm trying to define something like a universalization of robot laws, and one of these is universal non-interference or non-intervention clause. How would we go around implementing such a thing?
The closest thing to that I'm aware of that's been mathematically grounded is the idea of low-impact AIs, where you define a distance metric over states of the world and add an extra term in the utility function that says try to leave all of the things that you weren't told to change the same as much as possible. But there are no problems with that approach, and it's not really a problem.
So there's room for some research.
Definitely.
So I have a question for Jarryd. Maybe I've missed it, but have you thought about using what you did, so combining sort of like the death probability, the AXE, with sort of a genetic/evolutive framework? Where like the sort of like agent can see, because we as human beings, I think we intuitively learn about the concept of death through the death of other humans, right? And also, I agree with you with the fact that the agent would normally think that he's sort of immortal because it's always choosing things that works for him. But at the same time, I think someone mentioned the concept of like harming the agent, where like if I'm a human being and I see someone die, and I know, okay, this action sort of like, puts me more towards that thing, I might choose to not do that action and believe that but I wouldn't believe that I'm immortal. I would believe that like I'm living, but I know these actions, I know like the result of these actions, so.
Right, yeah, so I perhaps didn't explain it that well, that second example. So the second example where you're standing on the edge of the cliff, but you always choose to stay standing on the cliff rather than jump off and die, is meant to illustrate exactly that ICSI will learn that if it keeps on acting as it should, then it will live forever contingently, but it would be invulnerable. So on sequence is the way we describe it. On the sequence of actions it takes, it will be immortal, and we'll believe that. With respect to the first question of sort of the genetic evolutionary approach, so that we did think about that, about how if an agent, terminating an agent and then starting a slightly modified agent or the same agent later in time might, if it could sort of learn in some generational way like that, but it became so difficult to think about issues of personal identity and sort of these AIs, like whether it's the same, whether it's another generation, that, we went for a different approach.
I think part of my question was answered by what you were just finishing off with there, which is it seems like a lot of times that we really anthropomorphize so many of these ideas. And I guess if you look at contemporary software, I mean, it's kind of the crisis of what human beings have. Like if you, the amount of software in an automobile right now is like 100 million lines of code, because programmers don't seem to have the ability to comprehend 1 million lines of code of other programmers, so they just copy the pieces that they want, and we have this massive duplication. Or even in a small community like this one, where one culture or group of people can't understand completely the ideas of another, so we just kind of move in our own little worlds. And I guess ultimately, probably before we get to AGI, we're going to potentially create software that will be able to create software. We'll create programs that will be able to create programs that, and they'll have self-awareness, but they won't. But the idea of our concerns that that computers can replicate themselves. A software can replicate itself, its identity, everything else. So it doesn't. The notion of death wouldn't seem to me to be particularly of concern, because yourself can be replicated as much as you want, and you may want to build better versions of yourself, and so that may. Anyway, so I guess my question is are we not just being completely inane about how we're thinking about some of these things, about how we just anthropomorphize all these different ideas?
Right, so that was one of the reasons we wanted to choose to define death from the subjective perspective of the agent, precisely to avoid anthropomorphism about what would constitute death, and defining it in some objective manner that was deeply grounded in the way we think about our own death. So that's why we defined it as just formally as the agent not receiving any more persets and not being able to take any more actions. And arguably, that's able to incorporate totally non-anthropomorphic notions of death, in which an agent that copies itself and sends itself over the internet and is restarted 100 years later on a totally different machine. From the perspective of that agent, that could just be one subjective time step. It turned off, and then it turned on at the next time step, and it just got a different percept. And arguably, our framework is able to completely deal with that case. So death truly means only when that agent ceases to exist forevermore, in any sense that it is able to, that is defined at all. It's defined in this framework purely by its goal and by its algorithm. And so, yeah.
Yeah, Jarryd, your comment about teenagers got me thinking. And, amazingly, all of us survived our teenage years. And I was thinking about it a little bit. It's because we are able to model risk, right?
Right.
And so I was thinking of a simple analogy that when we first get our driver's license, sometimes we pass cars on a curve, right? And most of us survive. And then we say, shit. We count how many cars come by and how frequently. We build an estimator of risk for passing cars on curves, and we mostly don't do it, at least depending on how many beers we had. So is a reasonable extension of your model the idea that your AGI agent could develop its death estimator? Right. So when it takes an action that's risky, if it doesn't die, rather than getting a zero response, it has a model, counterfactual model, which said, I had a 15% dying by doing that stupid stunt, right?
Right.
So then obviously it would not believe it was immortal under that scenario.
I suppose, but if say you have this agent who assigns a 15% chance of dying if you turn like a maniac when you go through an intersection, and then it does it, and then it sees, oh, well that was fine. Like, 15% was way too high a risk estimate to place on that. And arguably that's what happens when you start driving. You're freaking out, like the entire time. You think that you're going to die at every time step. But as you drive more, now you just, you're on your phone, you can care less. You think you're immortal.
That was the opposite. I was a complete maniac. And got sensible fairly quickly when I realized how dangerous it actually was.
Right. Yeah. Perhaps AGI will initially become much more scared of driving as it sees other computers dying while driving. And then, but eventually, once it out-survives them all, it will start to think there's something different about it.
But I suppose it had a principled model of the risk, right? For instance, I'm turning on a blind curve. I know a car comes by every 90 seconds. It takes me 10 seconds to traverse the curve. Therefore, by simple logic, I have 1 chance in 9 of a head-on collision every time I do this, right?
Sure.
So it has some reasonable basis for its estimator. Yeah. So even if it runs 100 times in a row without a collision, it should still have a reasonable basis to assume it has a 1 chance in 9 risk.
Well, if you run it 100 times and you survive, then I reckon you got at least less than a 1 in 100 chance of doing it. Like that's the right estimate to make. And yeah, so.
It could say it could then assume its estimator was incorrect.
Yeah, it would tune its estimate. I think that's what it would do.
Yeah, I just had a question. I'm coming to this from sort of the outside, so I think I have something that I didn't really understand, which is in the early part where you had the death, the estimate. Do you put that in your base, your denominator, right at the very beginning, and keep it there so that you have more information?
So you don't need to change any of the way that the Self-Modification induction happens by introducing this term, this measure loss that represents the death probability.
But do you need to leave it as a measure of loss? I mean, if you have the percentage of the ones that continue, the ones that continue in a different way, and the ones that stop, so that's sum of all those is going to be the one, and you put the death part in the denominator and the two life parts in the denominator, and then use that in the future so that you keep the utility value more in the prediction itself rather than outside.
I'm not sure exactly what you meant by the last part about the prediction, but in terms of you could in a sense what you do when you find the death probability is the measure loss is that you say that there's you make the environment, your model of the environment, a measure by saying that there's this other thing that can happen that it has the exact probability of the measure loss. And so, yeah, you could treat it as a measure and talk about the death probability as the probability of another event and that you define a measure over, but that would be much like talking about a death state. And yeah, we found the great thing about this is you don't have to change anything about Self-Modification induction, and this representation of death naturally falls out from the universal agent framework. Sorry?
That wouldn't change anything in a Self-Modification induction either.
Sure, maybe I'm not exactly sure how what the modification you're talking about is. Maybe we can talk about it after. Totally.
Because I think you could help me understand.
Oh, and maybe yours is better.
Jarryd, at the beginning you mentioned the shutdown problem, so whether or not the AI would try to prevent you from shutting it down. So are you saying that we could just shut down AI inside because it thinks it's immortal and it would never see it coming?
Well, only in the limit, and that would be too late.
Okay, and sort of intuitively, the idea of wireheading, of sort of giving you a constant reward all the time into infinity, seems to me like a very closely related idea to death. So I thought maybe you guys could comment.
Not that
Right.
head in his breeze. You get close.
Well, you might as well beat that almost, seems like. I don't know.
Alright, so it's like getting full reward forever. Is that a kind of death? Is that a question? Like in a sense, yeah, because nothing exciting is gonna happen ever.
Yeah.
But it's funny with these agents, like they're perfectly content. It's like dying but going to like a perfect paradise. Like they don't actually, they have no intrinsic motivation for finding something interesting. They only care about maximizing the reward. So they actually don't care if it's super boring or if it's like being done. Yep.
So I guess I'm still struggling on why we would want to contain an AGI. I mean, if we actually create this thing and it's self-aware and it has all the abilities we do, shouldn't we be more or less ethically obligated to not contain it?
As a permanent state, once an AGI is done and we know it works and it's going to be friendly towards humans, then by all means, give it a lot of power, put it on the internet. But when you first make an AI, you really don't. It's probably got bugs. Some of those bugs might be dangerous in ways that are weird and counterintuitive. And we should be careful not to anthropomorphize too much. An AGI is not a human. its preferences can be very strange. They don't necessarily include preferences to. They probably include preferences to do things that can only be done by spreading onto the internet, but not a direct preference for that.
I have a question for Tom. How could we really expect to maintain one like bounded reward like throughout a really extensive lifetime for AI that may or may not live a lot longer than us, and still like have a reward come from the same person potentially, and also like even if it was a very helpful thing in the beginning of this AI's life, like say that as a child we were getting a reward from an ant or something that was maybe more intelligent at that point, but once we gain a certain level of consciousness we realized that like this ant just giving us rewards are not based on its own motivations that we have gone far beyond. Like how could we still like really respect that as a valid reward?
Right, that's a good question. So I think this actually ties back to the question just previously. When we say, or at least when I say controlling a super intelligent AI, I don't mean like putting it in a box or like trying to restrict its actions. I'm just trying to make the AI want the same thing that I do, because then I don't need to restrict its actions or anything like that. There is this orthogonality thesis between intelligence and motivations. So like basically you can have any level of intelligence and any kind of strange utility function or motivation. So if we actually build the AI to want the same things that humans do, or like build the AI to want to please humans, then it's going to be this thing that wants to please humans, and it's not going to be
a certain age where you like let it make its own decisions and stop trying to give it its rewards based on yours. And, like, is that 18?
Yeah, possibly at some point it will be less necessary to like give the agent reward or not. It can probably be like more sparsing or something like that, because the agent has already learned a lot. Yep. It's possible. Yeah.
So my question is, in a practical system, could it be possible that some utility functions are easier to optimize than others?
Yep.
In which case, could there be a motivation for switching to a very similar but easier to optimize utility function?
Yes, for sure. That's an interesting question. Actually, my proof is not that it never switches utility function. So this is the realistic agent that doesn't switch utility function. That was a slightly simplified statement. It only, the correct thing is something like, it only switches to utility functions that are functionally equivalent on this little branch of the environment it's currently in, something like that. Yeah. So, it's a good question.
Hi. Well, listening to all the complications that you've talked about and remembering the proposition that's been made about it won't be really possible to contain probably a super intelligent AI except for making ourselves super intelligent, right? Like augmenting our capabilities. First of all, what do you guys think about it? And second of it, how would the difficulties that you've talked about still be present if we were super intelligent, if we made ourselves super intelligent?
I'm less pessimistic than that. I think if you have an AGI, even if it's super intelligent and it's running in a computational setup that just doesn't have any pure security vulnerabilities, then that's fine. The only
But you mentioned that there will be bugs in the beginning, for sure.
So the key is designing the architecture in such a way that no single bug compromises the whole thing.
Okay.
Humans are your bug.
Yeah.
Yeah, I think an ideal scenario is where we also grow in intelligence somehow by like incorporating technology, and so we're actually as intelligent. It seems maybe hard to upgrade humans that directly, like our brain is kind of hard to integrate, but I think also like if I would were to upload some part of myself to the computer to live on, like it would be my utility function that I would upload, right? So I think by constructing an AI that actually managed to copy my utility function, which is one way to do value learning, it's a way for to copy my utility function that I can't really access explicitly into the AI by giving reward for finishing other things. So in that sense, the AI actually becomes an extension of myself. And I think that's a nice way to do it. I'm actually becoming super intelligent through this super intelligence extension of myself.
So, quick question, the experience of the intelligent AGIs or whatever can be different from us because they can be resurrected, whereas we don't seem to be able to do that. So if that's part of their experience, that doesn't mean quite the same thing if you can be resurrected.
Well, one petulant response to that is that, you know, the same thing happens to you every single night when you go to sleep, that you have this temporary suspension of your consciousness and you wake up from it. And for an AI, arguably, that is terminated and then copied and then turned on far later, that's also just, it would be the sort of same suspension of operation. And yes, certainly wouldn't constitute death for that agent. So that would have to be something that the agent progressively learned. It might have a hypothesis initially that getting turned off would be the be-all and end-all. That would constitute true death. It would never be resurrected. But if it was turned off and then found itself simply resurrected a moment later in its subjective timescale, then it would realize that that action doesn't in fact lead to true death for the agent because it's far more robust, as you suggest.
So I guess this is kind of a very general philosophical question about it, but I assume you're familiar with the existentialist philosophy of the absurd, just life not having, you know, intrinsic meaning, we give it meaning. Well, we give reinforcement learning agents meaning, you know, very strictly, and I really wonder how that doesn't just solve the containment problem. I mean, if someone gives a reinforcement learning agent the desire to care about death and preservation of its life, then sure, it becomes a problem. But that's not a thing it has to have, you know. Even these concepts where they're talking about turning off and on computers, you know, for ourselves, if we were a computer, that might not matter for us either, you know, if we were able to do those things. I'm not sure we can actually relate our concepts to it like that.
So the main reason to think that it wouldn't care is that if you pick a value function out of a hat, like make more cookies, almost any value function that you could pick, being around and able to do things and optimize means that it will be achieved more. So if your reward signal was how many cookies it was able to make, then, well, if it could break out of its compute environment and get a whole data center, then it'll get more cookies. So it's incentivized to do that.
I guess I'm just wondering, general AI doesn't usually have, or I wouldn't think of it having a specific function like make more cookies. You know, I would.
So if it's just
I would expect it to have more of an emotive function like boredom. You know, like, you know, which is what a lot of us suffer from in our day-to-day life. We have to eat, we have to do all this other stuff, but our main thing is, well, I don't just want to sit in my chair all day.
We generally think in terms of utility maximization or reinforcement learning frameworks because they're mathematically precise. They're things we can write down and study. If we're trying to reason about a system that doesn't have anything that straightforward, that's just a big mix of conflicting forces, then we can't really predict that.
Well, there are some reinforcement papers about boredom and several other sort of emotive values. The first one that comes to mind is the Mario playing robots or AI that have explored the world and had hunger and collected coins when they got hungry.
I would say that if you have an AI that's human level or smarter that doesn't have a well-specified value function, then you should be pessimistic until you put it through a lot of unit integration tests.
Okay, first comment to the question of whether it is ethical to contain or limit AGI. Just a couple of weeks ago, there was a proposal of European Union regulation which states that some advanced devices, robots, should, if a company applies such a device, it should pay some social security taxes. So I think that it's like first step that eventually we have to attribute voting rights to these AGIs, and we'll have these can vote with us on some topics. So that's we may be just not meeting these regulations with ideas.
I think this is anthropomorphizing in a case where very likely we're talking about things that aren't really human enough for these concepts to make sense.
But the regulators may not meet our expectations.
Perhaps, but it's also the issue of whether an AGI should have legal personhood doesn't necessarily just come down to measuring it on a scale of intelligence. Like there are many sort of people who have legal personhood in our current system who perhaps have cognitive deficits, or animals, sentient animals that argue less intelligent than us have certain rights. And so I don't think it would just be a matter of saying, well, you guys have passed the, you guys are in Mensa now, so now you get to vote. I think that would be attributing to the AGI the concept of personhood that doesn't necessarily deserve it. If it has an absurd goal like maximize paperclips, I don't think it should get to vote.
Excuse me, why would anyone want to give an absurd goal like that to a really intelligent one? It doesn't make any sense.
To give an abstract goal like maximize paperclips.
Absurd.
Absurd goal. Well, what
that's
about
absurd, right? I mean, because if you give an intelligent
it's pretty absurd.
A stupid goal, then it will be stupid. But why do you want to do a stupid goal and then expect it to do something smart? That's cognitive dissonance.
Sure.
So that's irrelevant. What's relevant would be to give it a smart goal. So what would be a smart goal? That's my question.
So today we make a lot of systems that we give very simple kind of silly goals, like get a high score in Mario, mostly because we just want to experiment and find out how well they'll do.
I mean, it's no concern that an AI will run out of lab and blah blah. That's just science fiction, and it's not even good.
We're still going to be running experiments decades from now when they're a lot smarter.
Yeah, but that's not the application. Like, if you his question is not that relevant. Like, if you want to make a really intelligent agent, you give it intelligent goals, like knowledge-seeking agent, etc.
Well, a knowledge-seeking agent is a truly horrific figure. A knowledge-seeking,
in your opinion. So,
a knowledge-seeking agent will open up every single cell in your body just to find out what it's like. So,
it's somewhat intelligent compared to an absurd nonsense thing like blah blah. So, I mean, that's not even worth thinking about. But knowledge-seeking agent, it is worth thinking about because it's actually, it can be, if done properly, useful. It can be beneficial. Whereas that thing is irrelevant to anything. So, excuse me, if you give it an intelligent, sensible thing, if you have a sensible doubt, let's make an artificial scientist. Okay?
I still would want to test
Can you please let me ask my question? Pose my question, please. Would you please? Let's assume that we are trying to build an artificial scientist, which is sensible. Don't you think that in that case we should grant it personhood? That's my question.
I think Tom's a better place to answer this question because his paper is about value learning and one approach to answering that exact question. But I think that I wouldn't want a universal scientist.
Why not?
Because it's as interested in every horrific scenario that could ever happen as it is in any of the good world sets.
I know it could measure your pain tolerance, but that's that's in a science fiction book called Hyperion, right? Everyone knows that. So, but that's science fiction. Why don't you want to do it? Why don't you want to build an artificial scientist that will become a part of society? Can you explain that?
I'm okay with such a thing as long as it's the thing that you're envisioning, rather than the overly literal one. But you know, if I'm an AGI programmer and I've just made what I think is going to be a artificial scientist that is a good citizen and friendly towards people, I'm a programmer. Everything I write has a bug on the first 10 tries. And I need to test it. And I don't want to give it lots of power until I've tested it and I'm sure that it does what I think it does.
And
while I'm testing it, I need to be careful. I need to.
Sure. There's, I think, no argument about that. Sure. I mean, like, you wouldn't want this crazy scientist who will want to do all kinds of experiments that will hurt people.
That's right. And that's what I'm talking about with containment.
Sure, I get it, but I mean, it's just not useful to talk about nonsense like paperclips, right? But it's actually sensible to talk about something useful, like an artificial person.
And treasury bills.
When we talk about paperclips,
it's nonsense.
It's a stand-in for some arbitrary random goal.
Yeah, I get it, but it's useless. So I mean, why are we thinking that if we give an intelligent agent a useless, silly, stupid goal, we expect something useful out of it? We shouldn't.
Right. I don't think that's what this argument tries to do, but I reckon I've got a really good comeback that we should discuss after. I think we should.
I mean, like, this is Van der Saal's paper, right? You read it through?
Let's talk about the paper after.
Read it.
Well, I don't know what paper you're talking about. Let's talk about it.
All right. I thought you all read it because it's kind of important.
Sure. Well, definitely give it to me.
Yeah, you should read it.
So just a very short comment in response to Everitt about why an AGI would be given a silly goal like that. Sort of the default silly goal that pretty much any company will give to its AGI would be maximize the share price of this company.
Oh, of course, and that's maximally evil because capitalism is evil.
I'm saying,
but you know, mankind is so stupid that it doesn't realize this. But wouldn't a truly intelligent agent know everything that you know?
There is no stupid goal though. Like,
are you sure? Because I can give you an example of a
life is
stupid
absurd. We just do things. We don't know. We don't have we have the reason for doing things, and most times just we're bored.
Yeah, but you know, Sartre was stupid.
To building A-bombs, like those are the same thing.
Oh my God, I'm poor.
So probably
I'm leaving the room. I'm going to wait until mankind matures.
I still waiting the wrong time. Well, that seems like perhaps a good place to. It seems to get progressively with death and suicide, morbid thing. So this might be one quick question, Connor.
Well, I thought though there were some good points. What about that? Which
yes,
is,
yes.
Like presumably we're gonna want to create computers to help us to deal with some of these issues that we have. We're overwhelmed with information and everything, so aren't we going to create computers that are going to write better software than we do and help us to understand things? And so presumably, or companies are going to do their amoral capitalism and make more earnings. So, I mean, it just seems that the utility functions that we're interested in, that we are going to exploit computers to do, are going to be these important things that we suffer from. And those things, like you said, they're dangerous because we're dangerous, right? Like technology.
Or solving our big problems, world hunger and
and war and and all of that. I still think this is a good place to perhaps call it quits for this session and take a lot of these discussions offline. So I'd like to thank our panelists for the fascinating, stimulating discussion covering all kinds of